Let's begin week 3 with a basic introduction to analytic functions in SQL. Analytic functions, which are also known as window functions, perform calculations against a set of rows and then return a single aggregated value for each row. They can be extremely useful for operations like calculating cumulative values, ranking rows, and performing year-over-year, month-over-month, and week-over-week calculations. These are just a few of the possibilities when working with analytic functions, and in this part of the course, we'll demonstrate several use cases for these powerful capabilities. Let's begin with a basic scenario regarding customer payments. I've already staged a query for us to use, which gets payment dates and amounts from the month of February 2007, and I've joined to the customer table to get first names and last names of our paying customers. Our task is to generate a cumulative total of each customer's spending for the month of February. By cumulative, I mean that for each date on the calendar and for each successive rental, the total that we calculate for each customer should be the sum of the amounts up to that point in time for that customer. That may sound a bit confusing, so let's demonstrate. I'm going to go to my query, I'm going to add a new line, and I'm going to start with sum of payment amount. Now at this point, if I ran this, the query would fail because we don't have a group by. But if I use an analytic function here, I don't actually need a group by. So how do we begin our analytic function? How do we begin the process of calculating that cumulative total that we want? Well, we're going to start with the keyword over, and then we'll open a parenthesis and come down a couple of lines and begin our analytic function inside our two parentheses. The next thing I'm going to do is I'm going to write partition by customer.customer ID, and then I'm going to say order by payment.payment date. The over keyword specifies the set of rows that the sum function will be applied to. Each set of rows within that function is referred to as a window. The partition by operator, on the other hand, tells SQL what windows we want to set. In particular, we are telling it here that we want to set each window to be each customer ID. If we don't use partition by to partition the rows by customer ID, then the window becomes all of the rows in our result set. To demonstrate this, let's look at an Excel file that I mocked up. In this scenario, we are partitioning by customer, and you can see that I have 9 rows in my table with customers A, B, and C and the amounts that they've spent. If I partition by customer, my first partition is customer A, my second partition is customer B, and my third partition is customer C, and so forth. And you can hopefully see that if I sum the amounts while partitioning by customer, then the result that I get from my analytic function is that it will give me a cumulative total for each customer. Then, when the next customer begins, that total resets from 0 and begins again, and so on and so forth. On the other hand, if I don't set a partition by in my analytic function, then every single row is my window, and the amounts will be summed across all of my customers without any partitioning. So next, let's actually alias our new function as cumulative rental amount, and then let's run it. Now take a look at the table in our result set. On the far end is our cumulative amount column, where we can see that for each customer, such as Mary Smith, we get a cumulative running total of their payment amounts, starting at $5.99, then adding 99 cents to get $6.98, then adding $9.99 to get $16.97, and so on, and so on, and so on, and so on, until we get to the next customer, Patricia Johnson. Now, she only had one rental, so her cumulative total for the month of February is just $2.99. But then we go down to Linda Williams and reset again at $8.99 and keep on going with her until we reach the next customer. Now, to demonstrate what happens if we remove the partition by, let's first go to our order by, and we're going to say customer.customer ID and payment.payment date. This way, the order by within our analytic function mirrors the order by in our select statement. Then I'm going to comment out the partition by and run the query again. Now, if we look at our table, we start with our first customer, Mary Smith, and you can see we start to accumulate totals. But then when we move on to the next customer, Patricia Johnson, we're still accumulating. And Linda Williams, still accumulating. Barbara Jones, still accumulating. And still accumulating on through all of our customers. And this is just going to keep on going until it gets to the end of our result set. This is why we use partition by. If I restore my code to its original state and just partition by customer ID and order by payment date, then each customer is getting their cumulative total ordered by the payment date in ascending order. So this gives us that running total that we want for each customer. Let's do another quick demonstration of how an analytic function works. I'm going to take my original analytic function and copy it and then paste it below itself. But then instead of sum of payment amount, I'm going to use min of payment date. Then I'm going to say this is our first payment date, and now let's run the query again. And what we'll see is that our new first payment date column is going to return the earliest payment date for each customer. So Mary Smith, her first payment date was February 14th, 2007, which we can verify by looking at the first row in her window. So there you have it, a basic introduction to analytic functions in SQL. Over the next several videos, I'll show you more ways to use analytic functions in Postgres.